The last example that we'll do today is looking at how we can both graph exponential relationships and fill out a table of values and make a graph from the table of values. Okay, so here the situation is we've got a colony of bacteria. It tells us that it grows exponentially. So there's a key term right there. It grows exponentially. The rate at which they grow remains constant over time. And the colony starts off with 50 bacteria and triples every 5 hours. Okay, so we know that the starting value is going to be 50. Okay, so 3 hours or 5 hours after that, the colony has increased by a factor of 3, and so now it's 150. So 5 hours later, it's going to triple again, and it's going to go to 450. 5 hours later, it will triple again. Let's go to 1350. 5 hours later, it's going to triple yet again. Whoops. It's going to triple yet again to 4050. Okay. And so what I can do now is I can actually graph this in. So I know that I've got a starting time of 0. So this is going to be my time in hours. So I've got 0, 5, 10, 15, 5, 10, 15, 20, and then I'll put a 25 there as well. Okay, and I know that I start off, I got to get up to all the way to 4,000. So if I look at how many spaces I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I go up by a factor of, say, 500, so this will be my 1,000 mark, my 2,000 mark, my 3,000 mark, my 4,000 mark, and my 5,000 mark. Okay? It's supposed to be 5,000. So if I graph this at 0, I've got 50. Okay, well, that's pretty darn low. That's going to be down somewhere over there. It's not 0, but it's not nearly high enough. 150 could be maybe right about in that area. If I look at 450 at 10 hours, I'm just underneath this line. At 15 hours, I'm at 1350. So 1350 is somewhere over in this ballpark. And then at 20 hours, I'm at 4,050. So 4,050. Okay? So what I need to do is I actually need to join together these dots in making my line. So I'm going to try and draw a line that connects these as smooth as I can. And then it would just keep going up from there. Okay? So if I want to try and approximate, so that I've graphed the relationship. So when will the number of bacteria reach approximately, not 36,000, but 3,600? Okay, so I want to try and figure out, well, how long is it going to take me to get to about 3,600 bacteria? So given my graph, I want to figure out first, where is 3,600 on the graph? So 3,600 is approximately here. Okay, so if I draw a fictitious line at this point, that will intercept my graph right at about this point. And now I need to go down, okay, to get time. So 3,600 is my horizontal red mark, and if I go down from there, Okay, I will probably get to about 3,600 uh, at just under 20 hours. So maybe about 19 hours and 30 minutes would be my guess. So about 19 hours and 30 minutes is a pretty good guess based on my graph and the data that I have available to me. So again, we can use our table of values. We can graph that table of values in order to see that this is in fact an exponential curve. And based on that, we can extrapolate using our best guess method uh, what the value of some particular amount of bacteria or the time if we make use of this line. So another thing we could do potentially is if you wanted to figure out, well, when uh, at what point do you have exactly 1,000 bacteria? Well, you could potentially do that if you knew, or if you want to know how many bacteria are there at, say, 12 and a half hours. Well, 12 and a half hours goes to about this area. So after 12 and a half hours, you'd probably have about 750 or so bacteria. Okay, so this method can be really useful in terms of figuring out different values along an exponential curve.